Welcome back, guys, to my channel, Mathematics MS Simplex. Today I'll be doing differential equation. First, I'll start off with defining a differential equation, then talk about the order of a differential equation, followed by the degree of the differential equation, and finally, the linearity of the differential equation. So let's get into it. Now, what is a differential equation? Differential equation is considered to be one or more derivatives of an unknown function. And believe it or not, derivatives represents the rate of change, and the differential equation is the one that defines the relationship between two of them. Now, the order of the differential equation is the order of the highest derivative. The degree of the differential equation is the power of the highest order derivative in the differential equation. Now, let's talk about the order of the differential equation. Now, remember I said the order is the highest power on the differential equation. So on this differential equation, you can see dy over dx has the power 1. So the order of this differential equation is 1. If you look at this differential equation, you realize the highest power on the differential equation is 2, so therefore the order is 2. So this must be a third order differential equation because the highest power on this differential equation is 3. So we have the first order, the second order, the third order. We can even have the fourth, the fifth, the sixth continuous to be continued. Now, the degree of the polynomial. Let's look at this example. So we have this differential equation. Remember, we said the order is the highest power on the differential equation. Looking at this, we have an order 4, and on this differential equation, d4y over dx4, we look at the power. Although the d square y over dx square has a power 2 on it, so as you can see, there's a bracket with a power 2. That doesn't mean that's a degree. The degree is on the highest order for the differential equation. So highest order is 4. It's on the first derivative that we're seeing, which is, so the degree is on d4 by dy over dx to the fourth. So power, we're not seeing any power. 3 is on the outer end, so it means that the degree is 1. Any power on the d4y over dx4. So since there's no power on this, then it means that the degree is 1. So this function is raised to power 1. So as stated, the order is 4 and the degree is 1. Here we have d cubed y over dx cubed raised to the power 2. On the first differential that we have here, the order is 3, and this is the highest order. So the power that is on this differential is 2, and this 2 represents the degree. So if you look at this one, what will be the order? What will be the degree? You should be telling me by now that the order is 2 and the degree is 5. Now, linear differential equation. How do we know a function is linear? It's based on the format for the first order, the second order, the third order. A linear differential equation consists of the dependent variable and all its derivative in the equation, and it's of the first degree. So it doesn't matter the order, but it has to be of the first degree. So it can be a first order differential equation with a degree of 1, second order differential equation with a degree of 1, third order differential equation with a degree of 1. So if you realize it doesn't matter what's the order, it's the degree that needs to be 1. So this is a general format for our first order differential equation where P and Q is classified as continuous function of x. So as I've stated, this function has Px and Qx are continuous function of x. Now for a second order linear differential equation, the general format is d squared y over dx squared plus px dy dx plus qxy equal rx. Now px, qx, and rx are continuous function, and looking at it, it's a second order with a degree of 1. So let's get into this activity where we will be finding which of these differential equations are linear. Let's get into this activity. First of all, is it a first order differential equation? You should be saying yes, because dy over dx is of the order 1. Is it of a first degree? You should be saying yes, because the power on the differential equation is 1. Can I identify what is px and qx? So just to remind you the general formula for the differential equation, px is the coefficient of y, so this is px, and qx is a continuous function after the equal sign. So seeing that it's in the general form that we have here, then it means it is a first order. So both dy dx and y are linear, so this is a linear differential equation. Let's look at another example. Here we have d squared y over dx squared minus y cubed equal to 2x. Now, looking at this, you say, oh, it's a second order differential equation of degree 1. But wait, we're seeing y cubed. That's different. If we look at the general formula, the y doesn't have a power on it. So the y cube is not linear, so the differential equation is not linear. Let's look at another example. Is this a linear differential equation? If you look properly, you're seeing ln y and not y. So that's the first thing you should be seeing. The general formula doesn't have any ln y. It must just be y standing by itself, being independent. Qx will be 0, but the ln y, that cannot be there. So with that being said, the ln y is not linear, so the differential equation is not linear. Let's look at this example. Is this a linear differential equation? It is of second order and first degree. That's what you should be seeing there. Now, although we're not seeing any y, that's okay. So yes, it is a linear differential equation because it's of the general form, and therefore we can say, yes, it's linear. Don't forget, guys, subscribe to my channel, like, click, subscribe.